Hi guys, welcome back to my channel. This is the second video on integrating factor method. This video we're gonna see how to use the method to solve two example problems. This should be very simple and very fast, so let's start. So the first example that we're gonna solve is ty prime plus 2y equal 4 times t squared. Okay, so we need to remember that in order to use integrating factor, we need to have equations in the following form: y prime pty equal g of t. So we need to transform our problem into that form. So, and that's easy. We just need to divide everything by y by t, and then we'll have this equation. So this equation is the one that we're going to apply the integrating factor method. So if you remember the integrating factor method, we need two things. We need to find a function mu of t that will be given by e to the integral of pt dt. And once we got that solution, once we get that solution, we're gonna use that to substitute into this formula. So in this formula will be the solution of our differential equation. So here we have mu t, gt, dt plus c. Okay, so let's do that. So here in this equation here, we have that p of t is just 2 over t. So let's find mu now. So mu of t will be e to the integral of 2 over t dt, and this is equal to e. So I'm going to put the 2 out there. This is just 2 ln of t. And if we keep solving this, we'll get e ln of t squared, and then we can simplify this and we'll get t squared. So mu of t is just t squared. So now that we have that, we're gonna substitute into my formula for solving the differential equation. So we got y equal 1 over t squared times the integral of t squared gt. But what is gt? So gt, remember we're working on this formula here. So my gt will be just 4t dt plus c. Okay, so we're gonna have y equal t to the negative 2, and this is just 4t cubed dt plus c. And if we solve that, we will get t to the negative 2. This will be t to the 4 plus c. And solving that, we'll get t squared plus c t to the negative 2. Okay, so y is equal to t squared plus c t to the negative 2. And here we get the solution of the problem that we were looking for. Okay, so as I said, very simple. Just make sure that if you're giving an equation like this that is not into that form, the first step is to transform my equation into that form. Okay, so let's do example number 2. So example number 2 will be, let's see, so we'll have y prime minus y equals 2t e to the 2t. So this example problem, it's already in that form that we want, so we don't have to do anything there. So we just jump directly into find mu t. So mu t is equal to e to the integral of pt dt, right? So in here pt is just negative 1, so we'll get e to the minus dt, and this is just e to the negative t. Okay, so we found our solution for mu t. And once we have that, we're gonna use that to to substitute in our formula. Let's write the formula again. So this is mu t gt dt plus c. Okay, so once we have that, let's substitute that. So we get e to the t here, and we get e to the t, g of t is 2t e to the 2t, and dt, oh here, sorry, it should be e to the negative t, and then we have plus c. Okay, so my y will be equal to e to the t, and this will be, I'm gonna put the 2 out here, and then I'll have t e to the t dt plus c. Okay, and once we have that, we only need to solve this part here, which we can do it by integration by parts. And if you don't remember integration by parts, basically we need a function uv, and then the solution will be in the following form: uv minus v du, the integral of v du. Okay, so in this case, we're gonna say that u is just t, and dv is equal to et dt. Then here we have du is just dt, and v is just et. Okay, so using that, we're gonna keep solving this, and we'll have 2 times. So the formula says uv, so u is t and v is et. So t e to the t minus the integral of v, which is e to the t, du, which is dt, plus c. Right, so we have a 2 there, and we have there. Okay, so we'll get e to the t, and here we get 2t e to the t minus 2, and here we'll get just e to the t plus c. Okay, and we can distribute this, and we'll get 2t e to the 2t minus 2 e to the 2t plus c e to the t. And this will be the solution that we were looking for. Okay, so in this video we covered 2 examples of integrating factor method. Again, one remark to make is that if you're not given the equation in the form, into this form, please make sure that that's the first step you need to take. Transform your equation into that form, and then find mu of t, and then use that mu of t into our formula here to get the solution that we're looking for. Well, again, thanks for watching my video. I'm gonna keep posting videos about differential equations. If you want me to cover another topic, I'm glad to help you, and I will make a video about that topic. If you like this video, please like it and leave a comment below. I'll see you in the next video.